Hi everybody, here's Christian from Team Warcast. Welcome to our Pico-8 Hero, Pico-8 tutorial about, we're gonna make Breakout. And so last time around we started to do collision detection and we did it very slowly, step by step, because it's a difficult process. There's a lot of math involved, but don't get discouraged. This is probably the most mathy thing that happens in this. Well, I lied. There is a second part of it that is going to be even more mathy. But we're halfway there. We're living on a prayer. Alright, so let me load Hero 1. Oops, no, not yet Hero 2. Load Hero 1. Let me run this real quick. Okay, so now, so far, we detect a collision, but we're not really reacting to it yet. We're just turning the pad red. That's all what we do right now. Before we begin, I wanted to do something because I got some comments in the Pico-8 forums, which I thought were really smart. Anti-Queen in chat, how are you doing, my man? So one thing is that somebody said is that we should put the variable declarations at the top where we create all our variables. We should put this into the init function. And I like this. I think that's probably a good idea. Again, I'm not really used to how the variables are working in Lua, so I'm still learning it myself. I'm used, you know, a lot of programming languages have the situation where they, you know, like go like dir, which is declare a variable, and then you have to declare all your variables, and then you can use them. And you cannot use the variable without declaring it. And usually the variable declarations go up top outside of every function. But in Pico-8, you can put them everywhere you want, and you can put them in the init function. I like this. The cool thing about the init function, putting them in init function, is that you know where they are, because as I said, with Alt and down key and up key, you can jump between different functions. And so if your variable declarations are inside a function, you can quickly jump to the init function, and there they are. Something that I also did wrong at some point, and I want to show it to you right now, is when we did this helper variable called butt press down here, I made a mistake here. I explained something wrong. See, what I said is that we're going to define a new variable called butt press, and that variable will be only valid within our update function. It will only be, it's like a small helper variable that is so-called a local variable, only available in the update function. But actually, this is not the case. Butt press is now available for all of our functions. So every function now has butt press. And I'm gonna show you how like that butt press is actually available everywhere by actually printing butt press on the screen. As you can see up there, you see false, and it also changes when I move the mouse cursor. Funny enough, it also changes color, which is weird. But yeah, if I press the button, it actually changes. So you can actually monitor the variable, which is useful when you debug stuff. But it's also, we realized that something is happening that we actually didn't want to do, which means the butt press variable is now available everywhere. In order to make it so it's not the case, you have to put a local before the first time you use a variable. So local butt press. So now butt press is a local variable. And you can see now it's nil. So it's tried to access the variable butt press, but there is no variable butt press outside of our update function. So it finds nothing. It's kind of funny that you still see something there. Oh, it changes color. Okay. But you can see butt press is now really restricted to the update function. And this is why we can define variables up here in our init function, and they will be available for other functions, because these are not local variables, these are global variables. Good. Cool. Good stuff. All right, let's save this just in case. And let us return. So last time around we did this crazy function. It seems complicated, but it's really not that complicated. It's really just a very simple. We check for the various collisions and we return false when we are sure that there is no collision, and if we go through all of our 4 checks. As a reminder, this is our beautiful sketch of the function here. When we eliminate all the cases where there can't be a collision, then the opposite must be true. There must be a collision, and then we return true as from this function, and then we can be sure that there's collision. This function we will reuse later on when the ball collides with other things. So now we have to deal somehow with the ball colliding with things, with our pad. So at this point, it might be interesting to see how did we do it previously. When we collided, you can see when we collided with the walls, we just inverted the speed of the ball. So for example, if it collided with the left wall, this is the left wall. Yes, this is the left wall. There we go. It's difficult to do this because it's mirrored. So if it collided with the left wall here, the ball was going in a negative direction, and then we inverted it, and it would go in a positive direction. So I guess we want to do the same, right? Let's try this and see what happens. So we're gonna just basically take this copy where we inverted the vertical direction. I'm just gonna invert the vertical direction. I'm gonna run this. Let's see what happens. It works. Perfect. So you could see like, oh, we're done. You can even put the ball underneath. That's really nice. I'm gonna want to show you so in a lot of cases this is actually good. But have you seen this? The walls, the ball behave very weirdly. Oh, it was caught in the pad. See? I'm gonna try to make it. See, it's getting caught in the pad. Why is this happening, right? And so this is. Don't be afraid. This is something that happens a lot, and it's kind of difficult to deal with this. But we're gonna have to. We're gonna try to deal with this. So I'm gonna use my paint skills again. I'm gonna blow you away again by explaining you what's happening. And it's kind of like you have to sometimes kind of like step through the function to realize what is happening. We're gonna step through the function right now. All right, so if this is our paddle, right? What is happening is the ball is coming in like this. Let's see, it's coming in like this. It hits, oops, I didn't want to do this. Can we undo this? Yes, we can. Let me do no fill. It's coming in like this, like so, right? And I'm gonna draw a line. Oh, I didn't want to do this. I see the problem. So it comes in like this and collides with our pad, right? And when it collides with a pad like this, we say, okay, let's check the code real quick. Yeah, we're inverting the speed of its vertical. So we want to make it go like this now. But you see, that's actually the wrong reaction now. It should reflect differently. Like if it came down like this, we would want to actually to reflect it in this direction, right? So we wanted to actually make it continue going downward, but reflect horizontally, not vertically, because it hit a different side. All our collisions are assuming that the ball collides like this or like this. And for all those collisions, it's fine. The ball behaves normally. But if it hits the pad from the side, it behaves not the way we should be behaving. So we kind of have to now detect where the ball hit the paddle. Did it hit it on the top, which is most of the times, or is it the rare case when it hit the side? And actually, that's difficult to deal with. Before we try to tackle this issue, I wanted to also mention one more thing, and that is what the ball then did when it reflected wrongly is that it moved upwards, but it was still collided. So it was like kind of like, I guess it was here. Let me show. So it was still here. Let's say it was here, right? And so on the next frame, the game still registered another collision. So, oh, we just hit the pedal. So it bounced him again in this direction. And then next frame, it was like here. Now we're drawing green over the sun, whatever. And then it reflected again. And then again, and again, and again, and again. So the ball was just caught in the paddle because we reflected it wrong. Grimtusk is asking, am I using chip or I'm using Pico-8? For these streams, I'm just using Pico-8 for Windows. But I do have also Pocket Chip. I'm using Pocket Chip usually like on the go, and you know, if I on the couch watching Netflix and coding stuff, that's all very, very comfortable. But for streams, obviously, it's a good idea to use this. Cool. So this problem that we're having, you've probably seen similar errors, mistakes in other games where two objects collide with each other, but somehow through some kind of bug or something, they don't disentangle and they keep being collided. And you cannot disentangle them because every frame the game thinks they're still colliding and doing stuff with them, and it's like they're behaving erratically. This is a very, very common issue, and most of bugs with collision detection and most of the programming that is required with collision detection are kind of like these kinds of problems where both objects are colliding and it's very difficult to get them outside. There is different solutions for this, but there's no like this solves all of the problems kind of solutions. It really depends on objects, the kind of game that you're doing, stuff like that. So for now, I want to create now a difficult function, a difficult function. Now comes the real math, guys. Strap yourselves in because this is going to be crazy. I'm going to show you the kind of functions I want to create. And I remember I was in Iceland. I was actually at the volcano that exploded, where the planes no longer could fly. You know, remember that thing? And one evening I sat down and, man, I'm gonna figure out this thing because I don't like how this is behaving. So I want to create a function where ball comes in. I'm gonna say like, you know, how the ball is moving. I want to be the function to say like, oh, now we're reflecting this direction, and when it hits this part, we're gonna go with this direction. And of course, I want to create a function that deals with every direction, every possible direction that the ball can come in. You know, I want to be able to see if I should reflect the ball very horizontally, which means it hit the side of the thing, or vertically, which means it hit the top. How I'm gonna do this? How the hell I'm gonna do this? This is crazy stuff. Well, here's my thinking. Here's what I figured. So let's say I have a position, that is the position on the last frame. And then I have a second position on the next frame, right? And then, so I can like calculate the angle between the two. I can also calculate the angle between the previous position and the edge of the paddle. Now, in cases where I want to reflect the ball horizontally, the angle will be between, you can maybe see already at the drawing, the angle between the two positions, like the angle at which the ball is flying, and the angle between the ball and the edge of the pad is going to be greater. In other cases, would be smaller. That's it. We're going to just compare the angles between our flight direction and one of the edges of the pad, and we're going to see if it's greater or smaller. If it's smaller, then depending how you count smaller, but if it's going one direction, then we're going to reflect horizontally. In other direction, we're going to reflect vertically. Now, this is difficult. This is super difficult. There's different solutions for this. I figured that solution out, but it took me some time. if you have a situation like this, where it's like, oh man, this is like some kind of crazy brainfuck functions, like how are we going to deal with this? It's a good idea to create like a test situation, because now it's like we have like this beautiful, we have this beautiful game where you can control a paddle and stuff like that, and starting to write a huge function like this is kind of like a pain in the ass. We would have to like lots of debug stuff. So it's a good idea now to start in a small test program, a small side program, where we can deal with this. Let me do this real quick. I'm going to save this. I have something prepared. I created a small program called test. I'm going to, oops, broke it immediately. I'm going to run it real quick. So this is the program. Oops, where is it? Ah, okay. So it's basically just a square. This is the square testing, and a line that I can control with the mouse keys, with the cursor keys. And this, and I can just move around kind of like the path that I'm testing against, and then I have some debug output telling me if things are going well. I'm gonna step real quick through the program to explain you what I mean. Like, here is the box, here are the coordinates of the box. If I change the coordinates, the box in the middle will change. Here's a position of the ray, the origin of the ray. The ray is the red line. And here is the velocity of the ray, so to speak. Like, this would be the velocity of our ball, for example. And then debug is hello there. Debug is basically just a text up there saying hello there. There's nothing in an init function. When I update, I just move around this origin of the ray, and the draw function just draws our box, creates a bunch of variables here. Oh yeah, these variables are just there to draw the ray. It just creates like how does it exactly work? I forgot. Whatever. It just there's a loop here, a repeat until. We haven't done this loop yet, but it's okay. You can do also for next loop, just to draw the different dots, the dots of the ray. And then we draw, we actually execute a function. This is our function. It just returns false all the time. This is the function that we're actually gonna have to write now. Deflex ball box. Beautiful function. Love the name. And let's go deflex ball underscore box. So it's called the same way it's called upstairs. In our main program. And basically, if it returns true. So our function is, if it returns true, then it means it deflects horizontally. Then this is our edge case where it hits the side of the paddle. And if it returns false, it means that we deflecting as we always do. We go upwards. We're deflecting vertically. And so the ball bounces there and then goes away like this. Yes, people are saying this is the part they always hate. I understand. Perfect, making like collision detection work nice and clean takes a lot of effort, but you know what? In this case, it's worth it. It's worth it because there's going to be a lot of collisions going on. There's a lot of collisions going on in our game with a ball and a square, and we try to nail this. So because it pays off. It's a thing that pays off. It pays off investing effort into this because this is something that happens a lot. That's generally something that good to think about in programming. Things that happen rarely or are not really a big deal in your program are not maybe worth investing that a lot of effort into, but something that constantly happens. For example, the movement of your character is something that's super important to nail perfectly. But let's say a start menu or something like this, or like a volume menu or something like this, doesn't happen too often. So there is a low priority thing. Like, you don't overdo it. Just make sure it's roughly usable, but you don't have to make it perfect. Cool. There's a hit detection, by the way. Hit ball box. This is basically a very similar function that we had previously. The only thing I did is I actually. So let me see. This is the way it looks in our program. That's the only thing. Like, I just put everything into one line, so it's a bit more compact. We can actually make it even smaller. I'm going to show you a way to make it even smaller. But it's basically the same thing. Just a bunch of math to see if there is a collision. So, do we actually check for this? We're actually not using this. Huh, that's interesting. So we can actually remove this, right? We can remove this, yeah. Let me see. Yeah, we can remove this. It's just okay. Good. Right. So how are we going to start this? How are we going to deal with this? So what I'm going to do now is I'm going to, because I already wrote this function and this was a bit of a pain, I'm going to actually copy and paste this function part by part. And we're going to go through the function and see how this worked. Let me see. Ah, that's nice. Okay, so a good start for a situation like this. First of all, just to be sure, like there's some arguments that are being transmitted here. So bx and by. Oh, so bx and by, I guess, is the ball. Bdx and bdi is the speed of the ball. Tx is target. Tx and ty is the left corner of the target, so this is the corner, and tw and th is the width of the box. It's a bit different. B is not the box here, but the ball. We have to actually transmit information about the ball now. It's not grabbing the information, but that's okay. Cool. So here is a first part of what we're doing here. Now, off the bat, there's some new thing. You have an else if thing going on. There's some commentary. Calculate whether to deflect horizontally or vertically the ball horizontally or vertically when it hits a box. Now, I'm gonna check for BDX. If BDX is 0, then return false. What does it mean? If BDX is kind of the horizontal speed of the ball. If the horizontal speed is 0, if it's 0, it means the ball is just flying like this. It's going vertically. If the ball is flying like this, it doesn't make sense. Like reflecting it sideways would make no sense. If the ball is going straight down, we're just gonna return false. We're not reflecting sideways. We're reflecting. It doesn't matter where it hit the paddle. We're just reflecting straight up. Same way if the vertical speed of the ball is 0. So in this direction, if the ball is going like horizontally, if it's not moving in vertically, then we always return true, because in this case, when it hits the ball, the paddle, we want to reflect it actually horizontally. So if you're making a complicated function like this, it makes sense to take care of the trivial situations, of the cases where it's like, those are very obvious. These are very logical and obvious. Right. Again, I wanted to return false here. I wanted to explain a little bit here this situation. So usually we're used to something like this, if and then we would start another if, something like this. If you have like multiple statements and you want to check, like if just one of these is true, then you can combine the multiple if statements into one big if statements that kind of like continues. So instead of like if and then if and another and, you can go else if. So else if, the things that is inside else if is only get checked if the first one wasn't true. So if box is 0, if that's not true, then we're gonna check if y is 0. If that's not true, then we're gonna continue and stuff like that. You can go like through a very long range of else ifs. It's kind of nice because also another thing you can do is just go else. And that means, you know, case 1, case 2, and then inside else there's going to be all of the other things, all other cases. So, you know, we're going to check if this is true, if bdx is 0. If that's not 0, then we're going to check if this is true, but only if this was false. If this was false, then we're going to check if this is true. And if both of these, if this one and this one are false, then always execute this. But if this is too complicated, you can also go very easily like with if statements like this. If and. It's very easy. It's like, you know, you don't have to do the else if. I like to do the else ifs because then all of the cases are kind of like the else at the end is kind of neat because then you are sure that one of these is always true. Cool. Right, so let us start with our first case. Ah, okay, got it. Good. So our first case is looking like this. First of all, I'm gonna return to else if. So basically, we checked, is it moving horizontally? We check, is it moving vertically? Actually, other way around, this is vertically. If both of these cases are wrong, then we are sure else that the ball is moving diagonally. This is going to be always the case, but later on we're going to maybe change the angle of the ball. So it was good to eliminate those special cases because of what's happening now. We're going to calculate the slope. This is a bit weird because usually you could there's multiple ways of how to solve this. You could create like an angle, right? You could like be like, okay, this is going to be the angle that we're going to calculate, you know, and this is going to be like, you know, whatever, 45 degrees. But in order to use the angle, we would have to use trigonometry and stuff like that. And I hate trigonometry. I mean, I like trigonometry. It's very useful, don't get me wrong. But it's not something I can do like from the top of my head. I would like to look up functions and stuff like that. And, you know, sine, cosine, and sine, a sine, a cosine, and stuff like that. It would be really weird. So what I like to do instead is a slope. And you might notice, like from your math lessons, a slope looks like this. So a slope that is 45 degrees, that's a slope of 1. Which means for every pixel that it goes to the side, it goes 1 pixel to the upwards. That's a slope of 1. The relationship between going sideways and going upwards is 1. If you have a slope like this, that's going to be a slope of 2 now. This is 2. For every pixel you go to the side, you go 2 pixels up. That's a slope of 2. And then, you know, a completely vertical slope is going to be infinite, sadly. So that's kind of like a downfall here. You can run into infinity issues. And if you're not going upwards and downwards at all, it's going to be 0. But you know, we kind of took care of those edge cases before. We checking if we were moving vertically or horizontally. So we know that we're not going to run into infinity issues. We know that the ball is always moving diagonally. So I'm calculating the slope. And you calculate the slope you divide it by, you know, how fast you're moving upwards against how far we're moving sideways. And that gives us some kind of comma value, some kind of value, weird value. That's going to be our slope. Then I also have like and there's a local variable I use, SLP, that's going to be slope. Why is it red now? Oh, that's weird. Did I did something weird here? Oh, I did something weird. Let's save this for now. And then I define a variable called CX and CY. This is probably going to be the coordinate against which we're going to check. Right. Now, we're checking if the slope is greater than 0. So here's the problem. Let me write something. If this is a ball, if the slope is 1, then if it's greater than 0, then the ball is somewhere here or here. If the slope is negative, then the ball is here or here, like going this direction or in this direction. This is the math behind this. So by saying like if slope is greater than 0, we know it's somewhere in the green. It's either going backwards diagonally, backwards and upwards, there we go, or in this direction. It's either those. And by checking if our horizontal direction is also positive, we are sure that we are in this quadrant. So we are sure the ball is going, as in our example, in this direction. This is the only check we're checking. We're just saying like in which general direction is our ball going. Moving down right is what I commented here. And if that happens, I'm gonna put in a debug Q1, which means this is Q1. Just so we know which direction the function is detected. And then, because the general direction of our ball defines against which corner we are checking. So if the ball is traveling this direction, this is the corner we're going to check against. If the ball would be traveling this direction, we would check against this corner. If the ball was moving this direction, we would check against this corner. There's 4 cases here, and this is the first of the cases. And the other cases are just going to be just copies of this. Right. So CX and CY, it's basically the distance between the ball and the corner we're checking against. So we calculate the distance here. And then we calculate basically the green line here, the little green line here. The slope of that green line. And then we check if, if the ball is... if CX is smaller and greater than 0, so if the ball is somewhere around upwards here, if it's either exactly above the corner or if it's right off the corner, then we are sure that we're going to reflect upwards. We're not hitting this part of this. If the ball started out somewhere here, then we are sure that we're going to deflect sideways. And then in all other cases, we're going to check the slope against the slope of the ball. And if the slope is smaller, if like this thing is smaller, then we're actually hitting this side here. So if, the green one here, this slope is smaller than this slope. It's a bit difficult here. But trust me, this works. So I'm going to run this. Let's see if this works. Is there any bug here? Okay. Oh, there is we haven't closed something. Let me see real quick. Else. Oh, all right, got it. Ah, right. So you can see we're reflecting vertically. Oh, somehow it disappeared. It's not working. Return. First of all, do we actually... see, that's a problem here. Oh, I see the problem. I see the problem. The problem is that we are in the wrong quadrant. There we go. See, because it said hello there. Hello there means we never set debug or debug variable to Q1. It stayed hello there as defined up here. So we already knew that the slope of the ball was wrong. And it was in the slope of the ball, of the direction of the ball, was such that it wasn't actually recognized by the program. So we change the slope of the ball. Now it says Q1 up here, which means our refined deflection function recognizes the slope. And as you can see, if I go over the corner, it switches between vertical and horizontal. It knows now, okay, now we would have to deflect in the other direction, and he would deflect upwards. So again, very simple, like not very simple. This is some hardcore math. If you see, like this is some crazy, it looks like I'm taking crazy pills. But really, we're just calculating the slope of the trajectory of our ball and checking it against the slope between the ball and a corner of the pad. And we pick which corner we're checking against by checking the general slope of the ball on the screen, general direction the ball is traveling at. Right, so now I am going to copy and paste, because we would have to go now through the rest, through all the other cases. We dealt with this case now. This is the case that we dealt with now. This is no longer necessary. This is being recognized correctly. But all the 3 other cases are not being recognized correctly. So now would be the case where we would go through those cases as well. I'm going to just copy and paste the entire function here. And I will try to make this function available to you guys so you can download this so you don't have to write it yourself. But basically, this is quadrant 1. This is the one that we've been dealing with. This is quadrant 2, moving up, right? So this is upright. No, this is this function here. This is this part. And, you know, it's basically the same. The corner is different, obviously. We're now dealing with this corner here, with this one, because it's going up. No, wait a minute, this is upright, this one. So here the corner is different now, and the slope checking is a little bit different now. But otherwise, everything's the same. Then this is Q3, moving left up. So this is now this part. Now we're checking against this corner. And again, the slope checking is a little bit different, but otherwise it's the same. And then else, we're moving left down. This is quadrant 4. Left down, this is this part. And here we're checking against this corner. Oops. Something is not quite right. What is happening? I think I renamed this differently. Yeah, there we go. So, you know, this is Q1. This is when the ball is moving downwards. I'm gonna change some of the signs here. This is Q3. Q3 was, I think, this part. So the ball comes from underneath the paddle. And you can see now it reflects vertically, now it reflects horizontally. And you know, you can now go through all of the cases here and make sure that it reflects correctly. Now this comes from top right, so you know, this is now this case where we're going this direction. Oh God, I'm running out of colors here. This is this direction. But yeah, good. So I am going to take this and I am going to copy it in our program and make sure that our ball deflects correctly. But that is something that comes in the next episode, where we're going to take this function and put it in our new program. Again, check in www for a full source code of this function. I'm going to scroll slowly through it in case I forget, so you can copy it in your program and make sure that you get it. Otherwise, if you have any questions, make sure to post them in the comment section and I will try to answer them. This was, I swear, this is the most difficult math thing that we ever did. It's super tedious, I know. It seems complicated, but now we have this under wraps. Now our ball will deflect correctly, hopefully. Let's see about that in the next episode. See you next time around, guys. Bye bye. Save.